Hello, good morning. I'm discussing some problems related to IR spectroscopy and solving the structural elucidation. Question number one, elucidation of organic compound. Molecular formula C8H8O, showing the IR band is 1590 per cm, but no band 3300 per cm. An absorption band at 1690 per cm shows that a carbonyl group is present in this molecule. There is no band at 3300 per cm indicates that molecule is not alcohol. Hence the structure is the acetophenone. Question number two. Two isomers A and B are having the molecular formula C3H6O. Choose the peaks in the IR spectrum. A 1710 per cm, B 3300 per cm. Find out the structure of A and B. Compound may be aldehyde, ketone, or unsaturated alcohol with isomer of A and B. Compound A have no absorption at 2600 to 2800 per cm, so that it is not aldehyde, but 1700 per cm, so it is ketone. That's why the structure is the propanol. The compound B, there is no peaks at 700 per cm, so that it is not carbonyl group, and 3300 per cm is the alcoholic, and at 1640 per cm is carbon-carbon double bond stretching. Hence, compound B is top 2 in all. Question number 3. A compound has the molecular formula C7H6O2, gives an IR absorption band at 1771 per cm on treatment with lithium aluminum tetrahydrogen. It converted into B, which shows the characteristic IR absorption band at 3300 per cm and 1050 per cm. Assign the structure of compound A and B. Tetrahydrogen lithium aluminum is the reducing agent of aldehyde, ketones, and carboxylic acid into alcohol. It is the carboxylic acid because it has two oxygen, not aldehyde in ketone. Absorption band 1700 71 per cm is the carbonyl group. Absorption band 3300 per cm is the hydrogen bonded alcohol. Absorption at 1050 per cm is the CS2. So the structure is the benzoic acid and benzyl alcohol. Question number 4. IR spectrum of acetone gives two maxima due to carbon-hydrogen vibration at 1360 per cm. Identify the stretching and bending mode. Express the maxima in micrometer. Bending vibration requires less energy than stretching vibrations, and absorption of air in case of bending vibration will occur at longer wavelength or lower frequency than in case of stretching vibration. The absorption frequency of 30-100 per cm is due to carbon-hydrogen bonding vibration. The absorption frequency of 3000 per cm is due to carbon-hydrogen stretching vibration. Maxima in micrometer, we know that 10 to the power 4 over lambda, so V bar equal to 1360 per cm, lambda equal to 10 to the power 4 over V bar, so 7.35 micrometer. If V bar equal to 3000, lambda equal to 3.3 micrometer. Question number 5. Indicate the expected absorption regions in the IR spectra of the following compounds: isopropyl alcohol, dimethyl ether, and toluene. Isopropyl alcohol, a strong and broad band due to hydrogen bonded ways stretching 3200 to 3400 per cm. This is the strong and broad banded due to hydrogen bonded ways stretching, and 1000 to 1300 per cm due to carbon oxygen stretching, and also 2850 to 2950 per cm is due to carbon hydrogen stretching. This is the due to strong and broad band due to hydrogen bonded ways, and 1000 to 3300 per cm is the carbon oxygen stretching, and 2850 to 2950 per cm is the carbon hydrogen stretching, carbon oxygen stretching, carbon hydrogen stretching. Dimethyl ether 1060 to 1150 per cm due to CO carbon oxygen stretching, and 2850 to 2950 per cm due to carbon hydrogen stretching of methyl group. Toluene 2850 to 2950 per cm is due to carbon hydrogen stretching, and 3000 to 3100 per cm due to carbon hydrogen stretching of aromatic ring, and 1500 to 1600 per cm due to carbon-carbon stretching in aromatic ring. Give the approximate IR bands in the following compounds: 3000 to 3100 per cm due to the hydrogen bonded OH stretching, and carbon hydrogen 2850 to 250 per cm due to CS stretching, and 1000 to 1300 per cm due to carbon oxygen stretching. In case of acetone, that is the 1700 per cm due to CO stretching, and CS stretching 2850 to 2950 per cm due to carbon hydrogen stretching. In case of nitrobenzene, 1330 to 1540 per cm due to nitro group stretching, 1500 to 1600 cm to carbon-carbon stretching and aromatic ring, 3000 to 3100 per cm to CS and aromatic ring. Give the approximate position of characteristic absorption bands of the carbonyl group in the IR spectra of the following compounds. Uh, compound 1, compound 2, third, fourth, fifth. These compounds. In case of first, the ethanol approximates 1740 percm. In case of second compound, benzaldehyde, 1700 percm. Compound third, acetophenone, 1690 percm. In case of structure IB, this is the approximate 1600 percm. And the structure B, 1690 percm. How will you distinguish between the following pairs of compounds using IR spectra? First, compound pairs first, second, third have given. In case of pair first, a strong absorption band at about 715 percm due to carbon-oxygen stretching in methyl-ethyl ketone will be obtained. No such band will seen in the spectrum of methyl vinyl ether. This is the methyl vinyl ether. Around 1000 to 1300 percm. In case of structure pair second, an absorption band about 1000 3050 percm due to carbon hydrogen stitching of CS2 double bond CH groups, and another band is about 1100 percm due to CO stitching will be observed in IR spectrum of methyl vinyl ether. Such bands will not form in the spectrum of methyl-ethyl ketone. Absorption about 3050 percm due to CS stretching of CS2 double bond CH group. Another band about 1100 percm is the CO stretching will observe in the spectrum of methyl vinyl ether. Methyl vinyl ether structure first, not second. Okay. Methyl vinyl ether shows the 3050 percm CS stretching and 1100 percm CO stretching. Will be observed in IR spectrum of methyl vinyl ether. Such bands will not be formed in spectrum of methyl-ethyl ketone. In this pair, both the compounds will show the absorption band about 1700 percm due to CO stretching. The spectrum of acetic acid will show an absorption band about 2500 to 3000 percm due to hydrogen bonded carboxyl group acetic acid, which will not observe in the spectrum of acetone. In case of acetone, the carboxyl group of acetic acid 2500 to 3000 percm absorption is not observed, but the carbonyl group absorption CO stretching 1700 percm is observed in the both of the compounds. In case of pair C, in orthohydroxybenzoic acid, there is a possibility of hydrogen bonding between the two groups as they are quite near to each other. Hence, we shall observe a band in the range of 2500 to 3000 per cm, while the metahydroxyl benzoic acid no hydrogen bonding, we shall see absorption band in the range of 3200 3400 per cm. Possibility of hydrogen bonding between the two groups in case of orthohydroxybenzoic acid, but possibility of hydrogen bonding impossible, not possible in the meta-hydroxybenzoic acid. So the band 2500 to 3000 will be observed in benzoic acid. But in case of meta-hydroxybenzoic acid, no hydrogen bonding, we shall see absorption band range 3200 to 3400 per cm. Question 9. Give the approximate position of the characteristic absorption bands of the carbonyl group in the IR spectrum of the flying compounds. Okay, there are 5 compounds. In case of first, ethanol, 1740 per cm. In case of second compound, 1715 per cm. And in case of third compounds, 1675 per cm. And in case of fourth, 1740. In case of fifth compound, benzaldehyde, 1700 per cm. Deduce the structure of saturated open chain compound C3H8O, which has a higher absorption band at 2950 per cm, but none near the 3300 per cm and 1725 per cm. A saturated open chain compound having the formula C3H8O can either an alcohol or ether. Thus, the possible structure are CH3O, CH2, CH3, CH3, CH2, CH2OH, and CH3, CHOH, CH3. There is no absorption band at 3300 per cm due to hydrogen bonded alcohol. Hence, the possibility of CH3, CH2, CH2OH, it means 1, 2, 3 propanol and 2 propanol is ruled out. Absence of band 1725 per cm rules out the possibility of carbonyl group, aldehyde or ketone. The only possibility of CH3O, CH3, it means methoxyethane, the band at 2950 per cm is due to CS stressing of alkyl group. Which of the following compounds could give rise to IR spectrum in the figure below? Acetone, propanoic acid, and propyl alcohol or ethyl formate. This is the IR spectra. We observed a band 300 per cm. This can be due to the hydrogen bonded alkali group in carboxylic group C in the when around 3000 in the area of the 3000 means here in this area there's the peaks. So we observed 3000 per cm. This can be due to hydrogen bonding of carboxylic acid. Since the acetone and the ethyl formate are not expected to give this band, the possibility of the compound being acetone or ethyl formate is ruled out. The spectrum shows a band at 1700 per cm, which is due to the carbon oxygen of the propionic acid, no such group is present in the propyl alcohol. 1700 per cm. See, this band also. Okay. Since acetone and ethyl formate are not expected to give this band, the possibility of the compound being acetone and ethyl formate is ruled out. The spectrum shows that 1700 per cm, which is due to carbon oxygen of the propionic acid, no such group is present in propyl alcohol. The band near 1300 per cm confirms the presence of propionic acid, and the spectrum relates to propionic acid. Another spectrum we see around 1300, 1200, 1400. This okay. This spectrum okay. Question number 12. IR spectrum of ethyl acetate shows three important bands. At 3002 per cm, 1742 per cm, and 42 1240 per cm. Attribute these peaks to the following features of the molecule: CH3 or CH2, CH3, CO, CO. 3002 per cm for the CS stretching of CH3 or CH2, CH3. 7243 42 per cm is the CO stretching. 1240 per cm is the CO stretching. Question number 13. Two isomers A and B having the molecular formula C3L6O exhibit the following peaks in the IR spectrum: 719 per cm and 3300 per cm, 1640 per cm. Write the structure of A and B on this basis. The compounds with the molecular formula C3L6O could be an aldehyde, ketone, or an unsaturated alcohol. A and B are isomers of each other. In the compound A, we do not have an absorption band at 2600 to 2800 per cm, which is due to the aldehyde CSO stretching, and the possibility of compound being an aldehyde is ruled out. A peak at 1710 per cm shows that it is the acetone. Isomers of A and B having the molecular formula C3H6O. In the compound A, do not have an absorption band at 2600 to 2800 per cm, which is due to aldehyde CSO stretching, and the possibility of compound being an aldehyde is ruled out. A peak at 1710 per cm shows that it is acetone. In the compound B, the peaks are obtained at 3300 per cm and 1640 per cm. There is no peak at 1700 per cm, thus ruling out the possibility of carboxyl group. The band at 3300 per cm is due to hydrogen bonded alcoholic group, and at 1640 per cm is due to carbon-carbon double bond stretching. Thus, simultaneous presence of an alcoholic group and carbon-carbon double bond is indicated. The probable structure is CH2, CH2, Prop 2-enol, allyl alcohol. Compound B peaks are obtained 3300 per cm and 1640 per cm. There is no peaks at the 1700 per cm, thus ruling out the possibility of carboxylic group. The band at 3300 per cm is due to hydrogen bonded alcoholic group. 1640 per cm is due to carbon-carbon stretching. Question number 14. The IR spectrum of methyl salicylate through the following peaks: 3300, 1700, 3050, 1540, 1590, and 2950 per cm. Which of these represent following structures? CH3, CO, OH group on the ring, aromatic ring. Methyl salicylate, methyl hydroxybenzoate. Various peaks correspond to the following structure: 3000 per cm hydrogen bonded OH, 1700 per cm CO stretching, 3050 per cm CH stretching in benzene ring, 1540, 1590 per cm carbon-carbon stretching in the benzene ring, 2950 per cm CH stretching in the methyl group. Which peaks in the IR spectrum could be used to distinguish between the two compounds, each of the given pairs? Ethanoic acid, ethyl ethanoate, and Dr. Second, trimethyl ammonium, methyl ethanamide. A peak around 2500 to 3500 per cm can distinguish between the acetic acid and ethyl acetate. and CH3COS and CH3COC2S5. Because such a peak will be given by acetic acid only, this peak corresponds to hydrogen bonded wedge stitching. In case of trimethyl ammonium and methyl ethanamide, a peak around 3300 to 3500 per cm can distinguish between the two compounds. The peak corresponds to nitrogen hydrogen stitching and will be given by only CH3 CH2 CH minus 2. Methyl ethanamide, because amine stitching is not possible in case of trimethylamine. Peak around 2500 to 3500 per cm can distinguish between acetic acid and ethyl acetate, because such peak will be given by acetic acid only. The peak correspond to the hydrogen bonded OH stitching. In case of second structure, the peak around in case of trimethyl amine and methyl ethanamide, a peak around sorry. In case of methyl amine, trimethyl amine, and methyl ethanamine, a peak around 3300 to 3500 per cm can distinguish between the two compounds. The peak correspond to NH stretching and will be given only methyl ethanamine, because NH stretching is not possible in case of the triethylamine. So easily we can distinguish between triethylamine and methylethylamine stock compound, a pair of compound second. Question number 16. A compound having the molecular formula C8H8O shows strong peaks at 1685 per cm. Which of the following is the likely structure of the compound? First, C6H5COCH3, C6H5CH2CH, and C6H5OCH, CH2. Acetophenone. A band 1685 per cm shows the presence of carbonyl group, hence the structure third C6H5OCH, 1685 per cm. Which of the following is the likely structure of the compound? There are two possibilities of phenyl methyl ketone and a phenyl acetaldehyde. Aliphatic aldehydes and phenyl substituted aliphatic aldehydes gives a peaks at about 1740 per cm. Hence, the possibility of structure second C6H5CS2CSO rule out, but shows the strong peaks 1685 per cm, so that possible left structure first. So the structure is the structure first. Question number 17. An aromatic compound having the molecular formula C8H8O shows an IR absorption band at 1690 per cm, but no band at 3300 per cm. Deduce the structure of the compound. An absorption band at 1690 per cm shows that a carbonyl group CO is present in the molecule. Absence of band at 3300 per cm shows that the molecule does not contain alcoholic group. Hence, the possible structure compound is methyl phenyl ketone. In a aromatic compound molecular formula, C8H8O shows that IR absorption band 1690, but no band 3300 per cm. 1690 per cm shows that carbonyl group. Absence of 3300 shows that absence of alcoholic group. Hence, the compound is the methyl phenyl ketone. Question number 18. Draw the conclusion about the structure of the compound from the following IR spectrum. The molecular formula of the compound is C7H8O. This is the IR spectrum. The absorption frequencies as observed in the spectrum are related to the groups H plus and aromatic carbon hydrogen stretching 3060, 3030 and 3000 per cm. Carbon see overtone in the 2000 to 1650 per cm. Carbon-carbon ring stitching 1590, 1480, ENF COC stretching 1245, 1030 per cm, CS bending 800, 740 per cm, CC bending 680 per cm. Based on the above observation, the structure of the compound is anisole, methoxybenzene. Indicate whether you will use IR or UV spectroscopy for distinguishing between the following pairs of compounds. Explain what basic distinction can be made. We shall use IR spectroscopy for the first pair because in the first compound we shall obtain characteristic absorption peaks corresponding to the carbon-carbon, COC and CS stitching. In the second compound, the absorption peaks will correspond to the CO and CS stitching vibration. In case of pair second, we use IR. In case of second pair, IR spectrum will be used for distinguishing between the compounds in the acetic. And the first compound, the peaks corresponding to COC and methyl CS stitching will obtain. In the second compound, peaks corresponding to methyl CS and hydrogen bonded OH stitching will be obtained. In case of pair second. In case of pair third, here we shall record the UV spectra of the two compounds. We shall make use of the fact that when the conjugated double bonds gives an absorption peaks above 200 nanometer. The first compound gives absorption maximum above 200 nanometer. The second compound does not. In case of third pair, we use the UV spectrum. We shall record the UV spectra of the two compounds. We shall make use of the fact that only conjugated double bond gives the absorption peak above 200 nanometer. The first compound gives absorption maxima about 200 nanometer, second does not. Question number 20. A compound has the molecular formula C7H6O2. It gives at higher absorption band at 1771 per cm. On treatment with tetrahydrogen lithium aluminum, it gets converted into compound B, which shows characteristic higher absorption band at 3330 per cm and 1050 per cm. Assign the structure to compound A and B. Molecular formula C7H6O2 have two isomers. Benzyl alcohol, benzoic acid, phenyl formate, phenol. Higher absorption band at 1771 per cm correspond to carbon-oxygen stretching in the compound C7H6O2. In the compound B, band at 3330 per cm correspond to hydrogen-bonded alcoholic group. Band at 1050 per cm is also characteristic of alcoholic group with formula C7H6O2. There are the two possible compounds which conform to the given data. Question number 21. Distinguish between propanol and propanol with IR spectrum, IR spectroscopy. The compound that absorbs around 1700 per cm is the propanol. The compound that absorbs around 3400 per cm due to waste stretching and around 1620 per cm due to carbon-carbon stretching is the propanol. What absorption band in IR spectrum could be used to distinguish between the acetone and ethanol? Acetone gives a band at 1700 per cm due to carbonyl group CO stressing, whereas the ethanol gives a band at 3400 per cm due to OS stressing due to hydrogen bondage. Question number 23. Oxidation of 2-propanol to propane is being carried out. How would you study the progress of the reaction with IR spectrum? Or 2-propanol on oxidation gives an ketone and dehydration gives an olefin. Explain the use of IR spectroscopy in the identification of the starting material and the products. 2-propanol gives strong band due to hydrogen bonded OS stretching at 3400 per cm on being converted into propanol. On oxidation, it gives an absorption band at 1700 per cm due to CO stretching. Okay, it's all about some problems related to IR spectrum in the structure elucidation. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. That's now. Bye bye. See you again.